Japan just launched the most aggressive tech crackdown the Western world had ever seen, banning 110 Chinese companies in a single night. China's response? Total silence. No angry diplomats, no emergency meetings, no retaliation announcements, just nothing. And that silence turned out to be the most dangerous thing Beijing ever did. Part 1. The night Japan drew the line. September 2024. No breaking news alerts, no dramatic press conferences. But inside Japan's Ministry of Economy, Trade and Industry, something that would reshape global technology was quietly being signed into effect. Overnight, 110 Chinese companies were locked out of Japanese technology exports. And these weren't small players. These firms were working at the frontier of the next industrial revolution. Lithography machines, AI processors, quantum computing hardware, and the cooling systems that keep chip factories from literally melting down. Western trade analysts called it historic, not just tighter than Japan's own previous policies, actually more aggressive, point for point, than anything Washington had done up to that moment. Think about what that means. The United States, the country that wrote the modern export control playbook, hadn't gone this far. And yet Japan, its closest Pacific ally, stepped further out in front, and the coordination was too precise to be coincidental. That same month, Washington added 23 more Chinese companies to its own restricted list. 13 of them were semiconductor manufacturers. Same week, same strategy, different capitals, one unmistakable message. Then Beijing went completely quiet. No WTO filings, no state media fury, no emergency summits, just silence. Here's what nobody in the Western press told you. That silence wasn't weakness. It was a weapon being loaded. Part 2. The empire that forgot it could fall. To understand why Japan made this move and why it backfired so badly, you need to understand just how far Japan has already fallen. Because this policy wasn't confidence. It was desperation in a tailored suit. In the 1980s, Japan didn't just compete in semiconductors. Japan owned semiconductors. Toshiba, Hitachi, NEC, Fujitsu. At their absolute peak, Japanese semiconductor firms controlled over 50% of the entire global market. Every other chip in every device on Earth traced back to Japanese hands. Then it collapsed. Samsung outspent them. TSMC out-executed them. Japan's giants, trapped by rigid corporate culture and shrinking reinvestment, watched decades of dominance dissolve within a single generation. Today, not one Japanese foundry can manufacture chips at 7 nanometers. Not one, in the entire country. And here's the part that genuinely stings. 7 nanometer isn't even cutting edge anymore. TSMC and Samsung crossed that threshold years ago. But SMIC, a Chinese chipmaker under some of the harshest American sanctions ever imposed, has already produced successful 7 nanometer trial samples. A sanctioned Chinese company cleared a bar that Japan's entire chip industry hasn't reached. Japan saw this, and rather than reckon with it honestly, it decided to block China's access to the tools that enable that kind of progress. Cut off the equipment, slow the momentum, buy time. The problem with buying time is what you do with it. Japan's answer is a government-backed foundry called Rapidus, $21.6 billion in public funding, targeting 2-nanometer chip manufacturing. The ambition is real, but pilot production isn't expected until 2028. That's 5 years behind where the industry leaders operate today. The gap isn't closing, it's widening while Japan waits, and the damage wasn't coming in the future. It was already here. 6-inch silicon carbide wafers, essential for electric vehicles and industrial electronics, once sold for around $1,300 each. Chinese manufacturers achieved mass production and dropped the price to $800. Japan's Rome Corporation slashed to $900 just to survive. The margins that funded growth simply disappeared. Low-voltage MOSFET chips, inside every refrigerator, every air conditioner, Japan's JS Foundry sold them at 40,000 yen per 1,000 units. Chinese competitors entered at 18,000 yen, a 55% price cut. JS Foundry lost its customers and filed for bankruptcy in 2023. These aren't trade statistics. These are real factories, real workers, real supply chains built across decades, dismantled in a few quarters. Japan looked at all of this and decided that tightening the chokehold on China's technology access was the solution. What Japan forgot is a rule that doesn't change regardless of the era. You cannot win a resource war when you control no resources. Part 3. China's silent weapon. There's a group of materials so obscure that most people will never encounter their names, yet so essential to modern technology that without them, the global digital economy begins seizing up within months. Rare earth elements, 17 metals sitting quietly in the lower rows of the periodic table. Names that sound like science fiction: neodymium, dysprosium, terbium, europium. They exist in parts of the world, but processing them to industrial purity requires massive infrastructure, specialized chemistry, and decades of accumulated expertise. China spent those decades building exactly that. Today, China controls between 85 and 90% of global rare earth processing capacity. That's not an approximation. It is a structural fact of the world economy that no political declaration changes quickly. Now look at Japan's position. Japan is a volcanic island chain with virtually no rare earth deposits of its own. For most of the last 3 decades, roughly 90% of Japan's rare earth supply came from a single source: China. And even after years of deliberate diversification efforts, partnerships with the US, Australia, India, deep-sea extraction research, Japan was still importing over 8,300 tons of rare earths in 2024, more than 5,000 tons of that, over 60%, still from China. Every alternative source combined adds up to less than 1/10 of China's processing capacity. Closing that gap doesn't take years. It takes decades, and during those decades, Japan's factories need this supply every single day. In November 2024, Beijing made its move, and the way it was constructed tells you everything about how sophisticated this kind of leverage has become. China didn't impose a ban. That would have been too easy to challenge at the WTO. Instead, Beijing built something far more precise. Any company anywhere in the world, TSMC in Taiwan, ASML in the Netherlands, Intel in Oregon, Samsung in South Korea, using Chinese rare earths to make chips at 14 nanometers or below, would need explicit written approval from Beijing. The content threshold, just 0.1%. The compliance window, fewer than 30 days. 30 days to restructure supply chains built over 20 years. The genius is in the legal architecture. By requiring approval rather than issuing an outright ban, China created a framework almost impossible to challenge under international trade law. The WTO can fight blanket prohibitions. It has almost no tools against a licensing regime that looks, on paper, like reasonable national security regulation. This gave Beijing something extraordinarily powerful: discretion. Approve friendly nations quickly, let adversaries wait in bureaucratic limbo indefinitely, without ever saying so out loud. America restricted things China was trying to get. China restricted things the world already needs to keep running. For Japan's auto industry, the backbone of the entire national economy, there was no clean exit. A single electric vehicle needs 2 to 3 kilograms of rare earth magnets. Scale that across Toyota, Honda, and Nissan's combined production, and the supply dependency becomes staggering. Recycling helps at the margins. It cannot replace industrial-scale supply. Japan tried to cut off China's path to next-generation chips. China responded by making Japan ask permission to make chips at all. Part 4. The device that changed the conversation. While Tokyo scrambled for alternative supply routes and Washington debated its own policy effectiveness, something happened inside China that quietly reframed the entire strategic picture. On May 19, 2025, Huawei placed a device on a table in Beijing that no Western company had yet brought to market. The MateBook Fold Ultimate Design. Unfold it. You get an 18-inch display. The largest foldable screen ever placed in a consumer product. Resolution at 3,296 by 2,472 pixels. Fold it closed. 13-inch form factor. Fully open, the device is just 7.3 millimeters thin. Lighter than most 13-inch laptops sold anywhere on Earth. Peak display brightness at 1,600 nits. Contrast ratio of 2 million to 1. A hinge mechanism delivering 400% more hover torque than previous designs. Starting price, roughly $3,328. Samsung's Galaxy Z Fold, a product Samsung spent years positioning as the global premium foldable, sits between $2,500 and $3,000. Huawei exceeded it on every hardware dimension. But the hardware isn't the story, not even close. Part 5. The operating system. Nobody believed was real. The MateBook Fold runs Harmony OS Next. And that, not the screen, not the hinge, is what makes this device genuinely historic. Here's a distinction the technology media has largely glossed over, and it matters enormously. Earlier versions of Harmony OS were built on Android foundations. They ran Android apps. In honest technical terms, they were modified Android distributions with a Huawei interface layered on top. That's not a criticism, it was a practical choice, but it's critical context. Harmony OS. Next is something completely different. New microkernel, new application framework, new runtime environment. Built from the ground up, it runs no Android apps. It contains no Android code. By every technical definition that carries weight, it is a fully independent operating system. To understand why that matters, go back to May 2019. The United States placed Huawei on its entity list. Google revoked Huawei's Android license. Overnight, every Huawei device in development lost access to the Google Play Store, Gmail, YouTube, Google Maps, the entire digital infrastructure that Android users treat as standard. For a consumer electronics company, losing Android is roughly like an automaker losing access to the engine. The product exists on spec sheets. The product customers will actually buy is gone. Huawei's response was not to lobby for relief. It spent 6 years and 130 million lines of code building a complete replacement from nothing. Harmony OS Next launched commercially in October 2024 with 10,000 applications. By January 2025, 20,000. By November 2025, over 300,000 apps and services, 30-fold growth in 14 months. The developer community now stands at over 8 million active builders. Every major Chinese technology platform committed. WeChat, Alipay, JD.com, Douyin, China's TikTok, which has more daily active users domestically than most Western platforms have globally, all building natively for Harmony OS. The market responded. In Q1 2024, Harmony OS captured 17% of China's smartphone market, surpassing iOS for the first time. By Q1 2025, Huawei and Xiaomi each held 19% of China's market. Apple had dropped to 15%. Globally, Harmony OS reached 5% market share by early 2025, making it the third most widely used mobile operating system on Earth. 3 years ago, it didn't meaningfully exist as an independent platform. Today, it's number 3 in the world. Part 6. The chip they said couldn't exist. The MateBook Fold also runs on Huawei's Kirin X90, a processor designed entirely in China, manufactured through a Chinese process, built without a single American-sourced component that export controls could reach. When Washington cut Huawei off from TSMC's fabrication, the prevailing expectation was straightforward. Without leading-edge manufacturing, Huawei's chips would fall behind. The hardware would become uncompetitive. The company would gradually fade from relevance. That assessment underestimated one critical dynamic. What happens when an organization with enormous resources and no exit options decides it simply has to build its way out? Through its investment arm, Hubble Technology, Huawei took strategic stakes in over 60 semiconductor-related businesses across the Chinese supply chain: material suppliers, fabrication equipment makers, testing firms, packaging specialists. The goal wasn't to produce one chip. It was to construct an entire domestic ecosystem capable of producing that chip, and every generation after it, without touching anything an American export order could reach. The result: Huawei's Ascend AI chips, built without U.S. technology, produced on SMIC's 7-nanometer process. Individual Ascend chips underperform NVIDIA's most advanced accelerators on certain benchmarks. Huawei's engineers know this openly. Their architectural answer: deploy clusters of 5 Ascend chips in parallel to handle the workloads a single NVIDIA GB200 manages. A brute force solution to a component-level gap. For enterprise AI computing, it works. Huawei is projected to produce 600,000 Ascend chips in 2026, roughly double the 2025 output. And NVIDIA's own CEO, Jensen Huang, assessed the result publicly. The restrictions didn't eliminate Huawei as a competitor. They pushed Huawei to stop depending on NVIDIA and build alternatives instead. NVIDIA's share of China's AI accelerator market dropped from approximately 95% in 2020 to around 50% by 2024. A 45-point loss in 4 years, not because Chinese firms couldn't buy NVIDIA products, but because they built their own that work. Part 7. The companies that missed the moment. While Huawei was engineering its way out of isolation, the companies that were supposed to benefit from its exclusion were running into severe problems of their own. Samsung's $50 billion semiconductor plant in Taylor, Texas, announced with enormous fanfare as proof of Western manufacturing reinvestment, has faced cascading delays. Mid-construction, Samsung pivoted from 4-nanometer to 2-nanometer technology, triggering costly redesigns and extended timelines. Tesla eventually signed a $16.5 billion supply deal through 2033, but commercial production won't begin until 2028. Apple is understood to be developing a large-format foldable device, the earliest realistic consumer availability, 2026 or 2027. Huawei launched its 18-inch foldable in May 2025. Apple has no competing product in the market today. Microsoft lost its Windows licensing relationship with Huawei in March 2025, a direct consequence of U.S. export control requirements. Huawei had already prepared. Every device the company launched in 2025 runs native Harmony OS. Microsoft lost an entire product category. The replacement OS it lost that category to is one that current U.S. policy makes it impossible to reclaim. Closing. The question nobody wants to answer. Step back from the individual products. Step back from the specific sanctions orders and licensing regimes. Look at the whole picture at once. A country was placed under the most comprehensive technology export restrictions in modern history. The assumption behind those restrictions was that isolation would create dependency. That without American chips, American software, and American-controlled supply chains, China's technology sector would stagnate and eventually reach for a lifeline. What happened instead contradicted almost every part of that premise. The pressure didn't manufacture dependency. It manufactured motivation. Huawei built a complete technology stack from scratch. Chips, operating system, app ecosystem, AI computing platform, wireless connectivity standard. None of it requires American inputs. All of it functions. All of it is improving. Japan moved against China with the most aggressive coordinated export controls the Western alliance had ever assembled. China looked at what Japan needed to keep its economy running, and quietly, precisely said, "You'll need our permission for that." The Mate 80 smartphone, launched alongside the MateBook Fold, features peak display brightness of 8,000 nits, nearly 3 times brighter than Apple, Samsung, or Google's flagship devices. That is the phone that American sanctions were specifically designed to prevent Huawei from ever producing. It exists anyway. Two parallel technological ecosystems are taking shape right now, one built on American standards, one built on Chinese alternatives that grow more capable with every product generation. Every government, every company, and every consumer on Earth will eventually have to navigate that divide. Japan tried to cut the cable. China built its own power grid. And here's the question this story leaves behind, one genuinely worth sitting with. When a company is told it cannot access the technology it needs to survive, and it responds by building that technology from scratch in 6 years? What does that tell you about the actual limits of economic pressure as a weapon? And what does it tell you about what's coming next? Outro. Threaded news. Most people see these headlines as distant trade disputes, political noise between governments. What they miss is the story underneath. The slow, expensive, determined process by which one country decided it would never again be dependent on another for the foundations of its own economy. And then, quietly, methodically, actually did it. That's not a trade story. That's a turning point. Here at Threaded News, we pull the thread. All the way through, past the press releases and the sanctions announcements, past the product launches and the bankruptcy filings, until we get to what's actually happening and why it matters to you. If this video gave you something real to think about, share it with someone who needs to hear it. Leave a comment below. We read every single one. And if you're not subscribed yet, now is a good time. Because there's a lot more thread left to pull. The story of the next decade is already being written. The only question is, are you paying attention? This is Threaded News. Stay curious. Stay informed. We'll see you in the next one.